Okay. Hello everyone, my name is Minh-Quyet. I'm so happy to be here today to present my research. The title of my poster is Descriptor Free Recommender System for New High-Entropy Alloys, an application of evidence theories. As we know that since the 2004, high-entropy alloys with the superior properties had attracted significant attention to scientific community. There are many methods that were studied to predict the element combination of high-entropy alloy using descriptor with parameters fitted to the available experiment data. However, there are some challenges remaining in these methods. Firstly, the small number of alloys have been studied among vast of potential alloys, so it's not guaranteed the accuracy of these methods. And the another challenge is that it's very difficult to design material descriptors that can be commonly used for alloys with different number of elemental species in their composition. To overcome the problem, we propose a method that applies the Dempster sample theory to recommend a combination of high-entropy alloy elements without using descriptor. To evaluate our method, we use two datasets that are constructed from 27 elements. The summary of the metadata of the dataset was shown in this table. And in the first data, we has only the binary and ternary alloy. In the second data, we has only the quaternary alloys. The dataset were estimated by using the calculation methods canvas, a flow database, and experimental observation. Now we move to our methodology. Our proposed method adopts the idea of substitution methods. It consists of two main steps. Firstly, we will measure the similarity between the combination of elements by model evidence from the two alloy AI and AG, and combine the piece of evidence by using the Dempster rule of combination. The obtained similarity matrix was used to recommend the new potential high entropy alloy by substitution methods based on the existing alloy AI, and the substitution methods are of CV to for CT in the alloy AI, and we can generate the new substituted alloy A new. And the property of the new alloy A new will related to the property of the alloy AI, and we will combine the multiple of piece of evidence to recommend the new potential high entropy alloy. The figure 1 shows the scheme of modeling the evidence of similarity between the two combinations of elements and modeling evidence of new alloy by substitution using mass function. And here we will show you the two experiments were designed to assess our methods. We will apply the two experiments in the two datasets were mentioned above. In the first experiment, we will evaluate the capability of recommending a new high-entropy alloy using cross validation. We apply the 10 9-fold cross validation and we repeat it 100 times. The 496 alloy in the dataset D chain will be used as a training set, and the model learned from the training set is used to rank the 2,780 possible candidates of binary and ternary alloys, is including the high-entropy alloy in the test set. And the figure 2 and 3 shows you the result of our similarity methods. And by using our similarity method, we can build the hierarchical cluster structure in the figure 3. And in the figure, you can see that there are two distinct groups existed in these 27 elements. The first group is a late transition metal, and the second group is early transition metal. In the heat map of similarity matrix in the figure 2, you can see that our methods show that silver and gold are very similar to each other with high level of confidence, and moreover, the element also similar to the manganese and the vanadium. To assess the capability of recommender system, we will monitor the dependence of the recall rate of high-entropy alloy in the test set with the total number of trials to recall these high-entropy alloys. And in the figure 4 shows you the result of the experiment 1, and our method need only 1% and 9% of all possible trials to recall the 50% and 80% of high-entropy alloys in the test set respectively. To evaluate the extrapolation ability of our methods, we use the model learned from the region and to rank on the 17,550 possible candidates of quaternary alloy. Remember that the region only contain the binary and ternary alloys. And we are ranking on the possible candidate of quaternary alloy, and we assess that by consider the recall rate of 754 high-entropy alloy in the test, and our model can recall the 50% and 80% with less than 4% and 22% of possible trials. In summary, our methods reveal the two distinct groups of early and late transition metal in the dataset, and moreover, the matrix obtained shows that the silver and gold are similar to each other and are also similar to the manganese and vanadium. And last but not least, the proposed application of the theory evidence is promising to recommend the new high-entropy alloys. Thank you so much for your attention, and don't be hesitant to give the question for me. Thank you so much.